measures of dispersion. Measures of dispersion. So measures of dispersion quantify the spread or variability of data points in a dataset. They help to understand how much the values deviate from the central tendency. So common measures of dispersion, we have number one, the range. So the range is the difference between the maximum and minimum values in a dataset. It is simple to calculate, but sensitive to outliers. So when it comes to the range, we have said if a student scored, the highest student in a test scored 60, and the lowest student in that test scored 20, and then 60 minus 20, you get 40. So that 40 is the range. So it is simple to calculate, but it is sensitive to outliers. So you are saying the range of that particular study is 40 in relation to that particular data set. Number two, variance. So variance is the average square deviation from the mean. The variance is the average squared deviation from the mean. So it measures the overall spread of the data, and the formula is variance is equals to sigma into x1 minus x bar bracket squared over n, which is the sample. So where x1 is the data point, x bar, x with a dash on top, x bar is the mean, and n is the sample size, right? That is the formula for variance. And then three, standard deviation. So standard deviation is the square root of the variance. It provides a measure of dispersion in the same units as the original data. The formula for standard deviation is square root into sigma. Then you have x1 minus x bar, x squared, x bar, bracket squared, divide by the sample. And that formula, you can see it there. And then we have interquartile range. So this measures them in quartiles. So the difference between the third quartile, Q3, and the first quartile, Q1. It measures the spread of the middle 50% of the data. So this is less sensitive to outliers than the range or standard deviation. So interquartile range, IQR, this is the difference between the third quartile, Q3, and the first quartile, Q1. It measures the range of the middle 50% of the data. It is less sensitive to outliers than the range or standard deviation.